All right. So it was quiz day earlier, but this is in between D and E day, I guess, however you want to count that. But these notes are hopefully review of like kind of the way back machine, right? Sixth, seventh, eighth grade science maybe. Um, we're talking about matter, we're talking about energy, we're talking about solids or compounds, elements, and mixtures. Gonna try to go quick just because I think we can. I think we can review this fairly quickly. So the strict definition of matter is that it's anything that has mass and occupies space. So it exists in front of you, it takes up space, it's matter. Right? It exists in three phases: solid, liquid, and gas. Things that are tightly packed, regular arrangement, definite shape and volume. Those things are solids. We're going to go from one extreme to the other. We have gases, and in a gas, particles are much... I don't know what just happened there. Why? Come on now. Huh. That's weird. Particles are much... Here we go. Sorry about that. Technical difficulties. Much further apart than they are in solids or liquids. They move. They just move. They don't depend on their neighbor. They don't depend on the thing across from them. They just move. Because of the distance, they fill to expand the area that contains it. Gas has no definite shape and no definite volume. Liquids are in between. Liquids are not quite solid, not quite gas. They do have a definite volume, but they take the shape of their container. So if I pour water into a bottle, it'll shape like the bottle. If I pour it into a bowl, it'll shape like the bowl, and so on and so on. Right, particle diagrams. We can use a particle diagram to show solids are tightly packed, liquids are slightly looser packed, gases are very far apart. Nothing crazy, nothing groundbreaking, hopefully. This is important right here. Matter is neither created nor destroyed in any process ever. And this is actually a science law. It's a law of conservation of matter. Matter is conserved. We don't get rid of it. We don't make it. We can turn it from one thing into a new thing, but you can't make it or get rid of it. It's just not a thing. If it looks like you've lost something, it means that it changed into something else. So for matter, we have these different properties, right? The first kind of property that we can measure a change in is a physical property. Physical properties are things that you can measure without changing what you have. So the color of something, the density of something, the mass, volume, right? Typical, kind of like your traditional five senses. If you have a change that alters the form of matter, so how it looks, how it feels, but not literally what it is, not its chemical makeup, just how it looks, then that is called a physical change. Now, if you have something that does change the identity, if you have something that changes the actual composition, the makeup of what you have, then it's no longer a physical change. You've made a chemical change. So combustion, if you burn paper, it's not paper anymore, it's ash, right? It has a different structure, chemical structure. Its composition, the way it's put together is different. It has different properties. If you took a piece of paper and ripped it in half, it's smaller, but it's still paper. It still acts like paper, writes like paper, feels like paper, right? There are some common phrases that you might see, right? The most common ones: burns, rusts, reacts with, combines with corrodes. Burn, rust, react with, combine with, corrodes. There was a quick break there. Reacts with, combines with, already forgotten. Oh. It's an actual chemical reaction. Decomposes, so decomposition. And the last one is a very specific reaction. I'm going to write it a little off the line because I don't have room here. And I want to make sure I spell it correctly. So what I actually think I'll do is just shift down a bit so I can actually write. It's electrolysis. Now, that won't be in a sentence. That won't be in the sentence like a student burns a thing, or a student witnesses corrosion, or they decompose something. Electrolysis is an actual experiment. Specifically, electrolysis is the separation of water into hydrogen gas and oxygen gas. So water is H2O, it's combined. You can actually take water and create hydrogen gas and oxygen gas by running electricity through it, hence electrolysis. Anyway, apologies for the delay there. We move on. Alright, so again, this might be a little bit of like the Wayback Machine, but once upon a time, you talked about elements and compounds and mixtures. Now, an element is a substance that cannot be broken down into simpler substances by a chemical change. It's something that we're not able to break down any further. Things like hydrogen, oxygen, aluminum, iron, right? These words that you recognize, they're all elements. If you can take two or more different elements and combine them in a chemical reaction, they form what we call a compound. Alright, so H2O, water. Two H's, one oxygen, put them together chemically, you get water. Carbon dioxide. Carbon, one carbon, two oxygens, you put them together chemically, you get carbon dioxide. They have to be very specific, right? They have to exist in a fixed ratio. So they contain two or more elements in a fixed ratio. It has to be certain amounts. You can't just eyeball it and say, yeah, it's kind of enough, let's call it this thing. No, no, no. It has to be exactly that much. And elements and compounds are considered to be pure substances because we're not messing around. They are exactly what they are. Now, on the other hand, you have a mixture, which is just a blend of two or more substances. You toss them together, you shift it around some, you get a mixture. If you have one with physically different parts, then we call it heterogeneous. Hetero like different. If you have one that is uniform throughout, then we call it homogeneous or homogeneous. Homo, same throughout, all right? Another name for homogeneous mixture is a solution. So salt water. If you put salt, you mixed it in water, and you looked at it, it looks the same all throughout. That's a solution. If you took Chex Mix and you mixed it up, It looks different throughout. That's heterogeneous. All right? Last thing we'll talk about is how to take the mixture and separate it into pieces. So, heterogeneous mixtures composed of liquids and solids can be separated two ways. You can use filtration, so you can filter it. You can filter the solid out of the liquid, or evaporation. Right? Heterogeneous are easy. You can filter it or you can evaporate it. Homogeneous mixtures like salt water, you cannot filter. You try to put a pitcher of salt water through a coffee filter, you have a wet coffee filter and salt water. Right? You can separate them physically, you just cannot filter them. Okay? There are special names that we give to the separation of homogeneous mixtures. That's not a star. There's some universe where I can draw stars. Try to remember this bullet point. These names. You can use distillation. It's used for a difference in boiling point. And you know what? I'm going to do a thing. I'm going to highlight. Right, distillation has to do with boiling points. That's very often a question. You could use evaporation. You can evaporate away the water from the solution. And finally, you could use something called chromatography. And I'm not going to have enough room on that line. So, I'll write below it. Chromatography. This is an A. Chromatography. 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 Right? You allow the solution to flow along a stationary substance. Now, some of these notes might not have been pure review. Maybe you didn't know this bit here about heterogeneous and homogeneous mixtures. Maybe you didn't know that there were heterogeneous and homogeneous mixtures, but hopefully you remembered mixture. Hopefully you remembered elements are the smallest pieces. Hopefully you remembered solids, liquids, gases, and their properties, their basic properties, right? You can see that I'm just on the same little whiteboard thing here. So these pages, right? That's as much as I'm going to say about those two pages for now. Oh, there we go. Okay. I don't know what's happening, but that's okay. This is as much as I'm going to do about those two pages right now. We'll talk about this flowchart and the examples on page 8 the next time you're in class, which will be E-Day. Right? Nothing to turn in. Nothing to do. Just make sure that you have these notes filled in. Alright? We'll be doing an example soon. This video's going on for too long. I'm out of here. Take care, kids.